So as you can see, guys, we have a lot of wires and they're all spread out. With the amount of power we're gonna draw for a robot and the hand welders, we need to make sure, even if we don't need the full length, we need to make sure that it's out so it doesn't overheat. But here we have a big generator that can run 12,000 watts. After that, it comes to a spider box, and after spider box, we go to a robot and couple of hand welders. The one reason we do this is because we need a constant power for our hand welders so that it don't shut off, and we can't rely on a customer's outlets, the old ones that are on the roof. The other reason is sometimes we can get away with having a generator on the bottom, pulling all the power up, and then running depending on how big of a roof it is.
55 amps.
55 amps. So we can run this and at least two. And at least two, yes. If we're not running a robot, we could probably go for no problem. So the very important thing that I want to mention, that all of these heat welders, including a robot, have an element. And if you all of a sudden have your power generator shut off, you only have a couple of seconds before you need to get that power on so that element won't burn. It needs to cool off. And every time we do shut off our hand welders and the robot, we need to put them on a cool mode, cool them off completely, and then shut it off. At the beginning of the day when we set it up, the robot needs to be set up to what kind of product we use, a PVC or a TPO settings, and what kind of weather we have. If we have a cold weather, the welders need to be heat up more. If we have a hot weather in the summer, then it needs to be less. Ted is gonna go over on that.
Okay, you ready?
Yeah.
Come over here, turn this thing on. It'll take a minute to kick on. Pull the trigger. You gotta pull start it. It push starts actually. You go like this, back and forth. So you want it to be 1148 degrees running.
For PVC?
For PVC. TPO is a little cooler. And depending on ambient temperature, how many feet per second you want to weld. 70% fan speed on PVC. I usually weld PVC and TPO about the same time. So you come over here. Set this up on your line. This is just going to be a test run.
And we do have to do a test run every day because
I do a test run on everything. Yes. You make sure you clean it real good, run your test run, make sure you're going to get a good weld.
We're going to talk about cleaning later on, but do you want to explain this thing right here? Why do we have it?
This is for the welder, clean the soot off it and what it creates.
Over time, guys, when you work with it, it gets built up of a rubber stuff that you need to clean off, otherwise it messes with the weld. So that's why it's there.
So you wait for it to heat up to 1148. And I'm not going to do 13 feet a minute. I'm going to turn it down to about 12.5. On colder days, you got to weld it a little slower. Hotter days, you can go a little faster. You got to play with it and see where you're getting a good weld. Huh?
For the machine, what totally saying, for the machine to start rolling, you need to push it hard enough so you can hear the click, and that when it activates the drive. So we're gonna let it cool off a little bit, correct?
Yeah. Let it cool for a minute. There you go, Richie. Now when you pull this apart, there you go. You should have, it should separate at the scrim and your weld should stay solid. So that's a good weld.
Before we do any welding, we're gonna do a tack weld. And the reason it's done is because when we run a welder, the membrane, don't move it anymore. And here's how it's done.
You want to make sure it's shoved all the way into the wall.
As deep as possible.
Yeah.
So that it doesn't interfere with the robot when you're going in. Let's talk about these.
And then any seams you have underneath the wall, you got to weld it out first. And you kind of want to see this stuff squirt out when you're welding. You want to weld about 750 degrees.
As we can see, we have another T-seam that we need to hand weld before we do a long
And you don't have to 45 your T-seams there.
Yeah,
because it's just membrane, and you're going to put a T-seam over the top of that anyway. It's just where two pieces overlap.
The bottom seam first, and then the top seam.
You line up your bear mat, get it all ready. Stick your welder in, pull the membrane up until it clicks and starts moving.
Talk about that little guide that you have when you're...
This little guide here is supposed to be on the top sheet of membrane. And then as you go, if you kick it out a little bit and stretch it, it won't wrinkle.
Don't do that. Don't do it too much. It didn't...
Okay, you're coming up to the drain, so the rest of it's going to have to be hand welded.
Oh, the drain?
Yeah. So then we'll take this over here and we'll
We're going to talk about what just happened?
yeah, the counterweight fell off. Yeah, you got to have the weight on there to push the PVC down as you're welding.
So you line up this.
So you pull the membrane, slide your welder in, put your foot alongside the wall, keep your membrane straight.
And you keep in line. That will roll.
And the rest will have to be hand welded. Then you come over here, hit cool, hit OK, let it cool down.
It's cool enough, and you're going to pull off. It's going to cut itself off by itself.
So when you're 45ing it back underneath, and then this piece comes over the top, we do that so you're not doubling up two pieces of membrane. So all you have is this little corner piece here. You put a T-patch over it, you're solid.
And then when we start welding, we actually start welding from the bottom.
Start welding the bottom first, weld this out, and then this gets welded over the top.
Sounds good.
So when you put two pieces of metal together, you want to leave a little space because the metal will contract and expand. So you leave a little space, and then we'll put a T-patch up and over this.
Underneath or
Underneath.
Underneath, yeah.
Similar to what we did in the corner. Right.
So when you're welding and you're coming from both directions and you're coming together, you always want to close off your weld. So I'm coming into that other spot, right? You always want to close your weld off, which means you're welding all this together from coming from both directions.
Squidge it in the metal and weld it.
Show me what you're doing.
Not on top of the tip. Running the robot. I hope everybody was watching it, right?
That? Because it's not, it wasn't cleaned properly with enough cleaner. Huh?
About end of a job. What are we looking for, Ted?
So when you're done with the end of the job, you grab a pencil and a probe, and you run your probe through your seams. And when you're probing along, you don't want to probe too hard because you'll destroy the membrane. But when you find a probe like this, you try to make it as big as you can without destroying the membrane. Mark it, and then where's that rag with cleaner? So right here, here's another one. And then you mark them.
And then you have one guy go in and weld them back. But this is basically how we finish our job. This is a QC. We gotta probe all the seams, that way we don't have a leak next time it rains.
And you run some rag and a cleaner in there. Ooh, that's beautiful. Something like this, you're going to want to cover up with a non-reinforced.
Patch. Okay.
And the reason you cover this up is because it's burnt. That's a leaker.
Can you mark it?
Yeah.